Have you joined Learnivio for other classes also, Darsh?
Yes, sir. Yesterday's class I joined for physics.
For physics. Okay. So the chapter solution, the first part on this chapter is about concentration terms. Okay. Mass percentage, volume percentage, molality, mole fraction. These type of things are there in concentration terms. Then you have solubility. Okay. So solubility is divided into two parts. Initially, you have solid in liquid and you have gas in liquid. Okay. Now gas in liquid is also, it also comes under the heading of Henry's law. Okay. Now these two portions are done. Concentration terms is done in this batch. Solubility is also done in this batch. Okay. So for concentration, you will have to come on Friday, 4 p.m. Saudi Arabia timing. Is that fine, Zarsh? Tell me. Yes or no? I did not hear anything, Zarsh.
Yes, sir.
Yes. Okay. Thank you very much. So Friday 4 p.m. KSA timing, we will be doing concentration terms. Okay. We'll be doing concentration terms. Now, the part about solubility and Henry's law, for that also I will give you some time, and then we can discuss with. Tomorrow, can you come at 4 p.m. tomorrow?
Yes, sir. I'm free.
Physics नहीं है कल? Physics कितने बजे है?
I don't know about physics.
कल कितने बजे था physics? Monday को?
4 o'clock ही था.
हाँ नहीं तो फिर physics वही time में होगा. नहीं है. So you are not free. So the classes here, they usually go like this. Monday, Wednesday, we'll have some class. Then on Tuesday, Thursday, you'll have some class. Then on Saturday, Sunday, you will have some class. Okay. So Monday, Wednesday, you're having physics. I think Tuesday, Thursday, you will be having chemistry. And you're opting. What is your other subject here? Biology or maths? So Saturday, Sunday में आपको bio होगा. कुछ इस तरह से रहेगा. ठीक है? Most probably ऐसा है मतलब एकदम ये नहीं है कि ऐसे ही होगा. But most probably it happens like that. ठीक है. तो Monday and Wednesday you will be having physics. तो उसमें नहीं बुला सकते. लेकिन Friday आप आइएगा 4 p.m. concentration terms we will be doing. And if I see that there is some time left, then I will also discuss these two portions. ठीक है. आपके साथ कुछ और बच्चे भी हैं जो लोग नए हैं, and they also have to learn concentration terms. Concentration terms के तो बहुत सारे बच्चे हैं. I think Matthew आपने भी नहीं किया ना concentration terms?
Yeah, I didn't do it, sir.
है ना? Nawal, you also, right?
Yes, sir.
हाँ ठीक है. So all of you will come on Friday 4 p.m. Saudi Arabia timing. आपको मैसेज भी चला जाएगा. ठीक है. Now after this we have, after solubility, the next portion is vapor pressure that we are going to start with. Vapor pressure. Okay. Now the reason why I asked that, okay, fine, you can come into this batch is because you don't need a in-depth knowledge of these two topics in order to understand the further topics. For example, vapor pressure, the only thing that you need from concentration terms and solubility is that mole fraction. So all of you know about mole fraction, right? Zarsh, you also know about mole fraction, right? What is mole fraction?
Mole fraction is number of moles in the solute B divided by the total number of moles.
हाँ, correct, है ना? तो बस यही चाहिए. Main information is this much, and then you can understand what is vapor pressure. Okay, is that clear, everyone? Yes or no? Please tell me.
Yes, sir.
Yes. Okay. Khalid, how are you? Khalid, yes, Khalid.
Yes, doing good.
Doing good. Okay.
Yeah.
Okay. Was it last time that we met on like Thursday? आपकी तबीयत ठीक नहीं थी क्या?
नहीं sir,
Khalid?
like before Eid, I
Like,
guess.
Before
After
Eid,
Eid,
before Eid it was, na?
after Eid class,
After
yeah,
Eid only.
yeah,
हाँ, after Eid. ठीक ठीक. But उसको time हो गया थोड़ा, है ना?
yeah.
Okay. So there is one more student. Hamza is not well. Hamza कह रहे थे कि Hamza याद है Khalid? You had Hamza and Hibana in 11th class, same batch?
Yeah.
हाँ. Hamza was not feeling well in the last week. तुम confused हो गए थोड़ा. Okay. Yeah. So what I was saying vapor pressure, I think, na? एक second. Let me see what have we done. Everything till here. शायद एक चीज नहीं कराया था हमने आपको, that is the graph of Henry's law. I think so. हाँ, graph में लिखा है. So we'll just do graph quickly, and then we will switch to vapor pressure. So all of you please write the topic, graph for Henry's law. Okay. Now, whenever you have to plot a graph, you need an equation for it, right? You need an equation for it. So the equation for Henry's law is partial pressure of the vapor phase. It is equal to the Henry's constant times the chi-b, that is the amount of solute or the mole fraction of solute in the solution. And as you can see in this graph, it will pass through origin. It is just like y is equal to mx, है ना? Y is equal to mx type of graph is here. So it will be passing through the origin like this. जर्श, वैसे आप ओरिजिनली कहाँ से हैं?
झारखंड रांची पे।
अरे वाह, आप तो बहुत ही नजदीक है हमारे यहाँ से।
आप कहाँ
लास्ट
से?
कब आए थे आप झारखंड?
लास्ट ईयर गए थे हम लोग।
लास्ट ईयर गए थे आप? कहाँ है? रांची में कहाँ रहते हैं आप लोग?
बरियातू सत्तार कॉलोनी में।
अच्छा, बरियातू में रहते हैं। ओके, बरियातू में डीएवी है ना?
जी
पता है आपको? धोनी बरियातू में ही पढ़ता था। कहाँ पढ़ता था? I don't remember exactly, but he was in some DAV only. Yes, Zarsh, कुछ कह रहे थे आप?
हम मतलब बरियातू से थोड़ा आगे है।
थोड़ा आगे बरियातू से। So I am also from Jharkhand, but I am from a very small village. आपको चाईबासा पता है?
जी, पेरेंट्स को पता है।
पेरेंट्स को पता है चाईबासा। So it is like near चाईबासा। चाईबासा के अंदर भी एक गांव है जगन्नाथपुर नाम का। If your parents know, तो उनको पता होगा जगन्नाथपुर। Even Khalil, you are here also from Jharkhand, ना? तो दो स्टूडेंट है, 3 लोग हो गए झारखंड के यहाँ पे। Khalil, you are from Hazaribagh, right?
No, sir. Jharkhand, Dhanbad district.
Dhanbad district. Dhanbad district. So this is the graph for Henry's law. Done all of you? Yes or no? Please tell me. Is everyone done?
Yeah.
Is there anyone who is still writing? No? All of you are done. Okay. All of you understand this graph, right? It is similar to y is equal to mx. अच्छा, यहाँ पे हम axis में लिखा ही नहीं, हम बात करने लग गए हम। यहाँ पे pressure होगा, and here you will be having chi-b. Also write the axis. Pressure will be on the y-axis and chi-b will be on the x-axis. Okay. Next is vapor pressure, है ना? So before starting vapor pressure, all these topics, let me tell you and explain what is vapor pressure, and then we can understand it. Okay. So there is a phenomena that all of you must have seen happening. Is if you have a container of water like this, you have a container of water like this. And you have a lid which you have placed over it. Okay. And what do? You keep this overnight. You keep this overnight as it is. And in the morning, if you look at the lid, then you will find some water droplets on the lid. Is that right? Yes or no? Please tell me.
Yes,
सबने
sir.
देखा ये, है ना? What about others? हाँ? Anya, Hishma, Matthew, Minashi.
Yes, sir.
Yes, all of you have seen, right? So that means, but initially there was no droplets of water, right, on the lid. Correct?
Yeah, initially it wasn't.
Right. Initially it was not there. Obviously, what is happening? Where does this water come from? This water came from, and this container was also closed. So this water came from the liquid water that is here. So what is happening? Some of the liquid water, it is getting evaporated, right? It is getting evaporated, and it is getting vaporized. And slowly, as it now here it is air, but as soon as it reaches the lid may be a bit cold, and because it is a bit colder than the air, what is going to happen? It will condense and it will form water, right? It will condense and it will form water droplets on the lid. Now, as we can see, if I have a liquid, what it is going to do? It is going to evaporate, and there will be a layer of vapor just above the liquid, right? There will be a layer of vapor just above the liquid. Is that clear? Yes or no? And the pressure applied due to these gas particles is called vapor pressure. ठीक है? तो ये जो vapor, please don't write anything, okay? Please don't write anything. I will tell you when you have to write. Now these particles of gases, they will be applying pressure because PV is equal to nRT, है ना? So P is equal to nRT by V. So if you have n number of moles and the volume is V and the temperature is T, then it will be applying P pressure, right? Then it will be applying P pressure. So here we can see that there will be a pressure applied by the vapor, and those vapor are formed by the liquid that is present, and that is why these are known as vapor pressure. Is this clear? Yes or no? Please tell me. All of you, please tell me, is this clear?
Yes, sir.
Yes, sir.
Yes. Right? Okay, fine. Now let us move on. Now, because we are not going to just study one liquid, we are going to study solutions. So let us take. There is one more term which is known as volatile. Okay. Hania, you are not able to unmute yourself. Acha. You can rejoin. I think sometimes this happens. If you rejoin, it will be fine. Okay. Try rejoining. Let me also plug in my earphone. I can't hear some of your voices.
Sir, did you like change your mic settings or something?
Why? Salman?
There's too much noise reduction on it, that's all.
There is too much noise reduction या बहुत ज़्यादा noise आ रहा है?
No, too much noise reduction, like your voice is compressed.
No, I did not do anything. How is it now? Same.
Yes, sir.
अच्छा same ही है. अरे
No,
सही
now
आ
it's
रहा
good. Now it's good. Now it's good.
Good, okay, fine. ठीक है. जर्श, वैसे आपका एक्स्ट्रा सब्जेक्ट कौन सा है? फिजिक्स, केमिस्ट्री, बायोलॉजी के अलावा?
Physical education.
अरे वाह, सही, एकदम सेफ, बहुत ही सेफ खेल रहे हैं आप तो फिर, राइट?
Yes, sir.
Okay. I'm amazed by those who take biology and maths. I'm like, okay.
I know, right? Some of my friends took it, and then at the end of the year, they're like, "Why did I take?"
है ना? So it's like I'm not यहाँ पे बहुत सारे लोगों ने लिया हुआ होगा, so I'm not telling anything about them, but generally what I have seen people do is that ज्यादा ऑप्शन होंगे ना हमारे पास, इसलिए ले लिया सर हमने, ज्यादा ऑप्शन होंगे, एंड देन द प्रेशर इज सो बैड, एंड दोनों ही इतना खराब हो जाता है दैट दे डोंट हैव एनी अपॉर्चुनिटी. ठीक है, बट आई नो इफ यू आर हैविंग हेल्प लाइक दिस, ठीक है, इफ यू आर स्टडिंग इन स्मॉल बैचेस एंड ऑल, देन इट गेट्स इजियर बिकॉज डाउट्स ही तो है. आफ्टर दैट यू हैव टू जस्ट प्रैक्टिस अ लॉट, राइट? then those doubts can be cleared easily if you are talking and interacting with teachers like this. है हानिया, आप अब अनम्यूट कर पा रहे हैं?
Yes,
हानिया, चलिए बहुत बढ़िया, ठीक है. अच्छा, now let us see that we have two different liquids. We have a liquid blue, which we will call this as A, and we have a liquid yellow. नहीं, येलो नहीं करते हैं, आप लोग पता नहीं क्या सोचिएगा. Let us take Ruafza type of thing. ठीक है, so here you have red. All of you know what is Ruafza, right? Yes or no? सबको पता है Ruafza?
yes, sir.
ठीक है,
Yes.
okay. अभी बताइए, here you have water and here you have Ruafza. आप दोनों में क्या कीजिए, इसको lid से ढक दीजिए, and you also cover this with lid. And जब सुबह आप देखिएगा, then what do you think, where will be the droplets more? A में या B में, कहाँ पर droplets ज्यादा होंगे?
In A.
All of you agree, yes or no? Please tell me. In A there will be more droplets,
Yes.
right? Why? You will say that, sir, because water will evaporate more if we compare it to Ruafza. So I will say yes. And if what is the, how can we measure the rate of evaporation? What we can do? We can measure the vapor pressure for both the things, right? है ना? इसमें भी we can measure the pressure that is applied by the vapors. Here also we can measure the pressure applied by the vapors, and we will see that the vapor pressure of water is more than the vapor pressure of Ruafza, and that is why we can also say that water is more volatile. It is more volatile than Ruafza. Is that clear? Till here, सबको सही है? Yes or no? Please tell me.
Yes, sir.
Yes. What about others? Nawal, Minashi, Mazia.
Yes, sir.
Yes, sir.
Yeah, everything is clear. Okay, fine. चलिए. So next thing, I'll start writing about vapor pressure, and you will be just copying with me. ठीक है? जर्श, आपको समझ में आया? Why the water will be having more droplets and vapor pressure भी उसका ज्यादा होगा? Yes or no? Please tell me.
Yes, sir.
Okay. So we have vapor pressure. So first of all, right, what is the definition of vapor pressure? The partial pressure of vapors Acha, if you remember, it will be happening like this now. You have H2O liquid, it is getting evaporated and becoming H2O gas. ठीक है? And H2O gas is becoming H2O liquid. Both of these are in equilibrium. So it will be the partial pressure of vapors that is in equilibrium with the pure liquid at a given temperature. Okay, so let us look at this equilibrium here. So initially I will say that rate of whenever we are having a equilibrium in which liquid is getting converted to gas and gas is getting converted to liquid, we have evaporation and condensation. So at equilibrium, and what is equilibrium? बताइए Samaira, what is equilibrium? Tell me Samaira, 11th में हमने पढ़ाया ना? What? How will you think about equilibrium, Samaira? Salman, Minashi, Mazia, Matthew, Khalil, Khalid, Ishma. बहुत लोग हैं. किसी को याद है equilibrium?
When the backward and forward reaction are equal
नहीं नहीं वैसे नहीं. और मतलब
or
थोड़ा सा
simultaneously
Backward and
happening.
forward reaction are constant.
नहीं. नो 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 वो वैसे नहीं वैसे नहीं. What is equilibrium? Does anything happens at equilibrium? Can you see? No. देखिए, this is the thing about equilibrium that you will always remember. ठीक है, शायद आपको अब याद भी आ जाए. Equilibrium is a state where nothing happens. And when I say nothing happens, it means you can't see a significant change in the system. Whatever things are happening, that they are happening in such a dynamic nature that there is no macroscopic change. There is no macroscopic change there. Do you remember this point? Equilibrium वो point है जहाँ पे कुछ नहीं होता है, where nothing happens. Do you remember these points? Samaira, Salman,
Yes.
right? So what is equilibrium? Equilibrium तभी होगा ना when you have nothing is happening, right? And in the macroscopic levels, in the microscopic, some things will be happening. For example, in microscopic level, अब जैसे आपने एक ग्लास रख दिया पानी का, ठीक है? You have kept one glass of water, then obviously evaporation will be happening, ना? Evaporation will be happening. अब जब evaporation हो रहा है तो उसका मतलब तो ये है कि water का level नीचे चला जाना चाहिए. But do you see that happening? Do you see that the quantity of water is getting lowered? Yes or no? Tell me. If you keep no, so that is equilibrium where nothing happens. It doesn't mean that nothing happens. Nothing, you can't see any significant change there. You can't see any significant change. So at equilibrium, sorry, I should not write it like this. This is the equilibrium reaction. But at equilibrium, what are the equal rate of evaporation is equal to rate of condensation, right? And that is why you don't see any significant change. Now, if rate of evaporation is equal to rate of condensation, then H2O. Now, please remember, ये जो हम दे रहे हैं ना, H2O is one example because vapor pressure will be generalized for liquids, but I'm starting with H2O because this is something that you have seen many times. You are acquainted with this example with H2O gas. Okay? H2O gas. Achha. Now, when we have written equilibrium, we can also write the equilibrium constant. That will be K. So products upon reactant. So in the product, what do we have? In the product, we have H2O gas. So for H2O gas, we will write what? For H2O gas, we'll write the pressure of H2O gas. Right? Now divide by H2O liquid. All of you know that for pure liquid, what do we take the concentration of the pressure as? 1. Is that right? Yes or no? Please tell me.
Yes.
If we have pure liquid, then we take it as 1. So this is Kp. This is Kp because we have only pressure term here, pressure of H2O gas. Now this is the vapor pressure only. This is the vapor pressure, right? So you'll write Kp is equal to pressure of H2O gas. Okay. And this pressure is the vapor pressure, and it is also a equilibrium constant, and it is also a equilibrium constant. Okay. So please write till here. Let me know when you are done.
Yes, sir. Again about the pink highlighted one.
Sorry, Salman.
Again about
Should
the
I
pink
repeat?
highlighted one. Yeah.
हाँ, ये बस 1 हटा दिया ना हमने. Where are you? Are you outside?
No, sir. I'm inside the house.
You're a fan. Okay.
Yeah, probably the fan.
It seems like you're an Indian train or something. Okay. Understood this, right? What are you asking, Salman? आपकी आवाज ही नहीं आ रही सही से. Can you write in chat or something?
Like the pink color highlighted one. Can you say about that again?
यहाँ से यहाँ आए हैं, बस हम 1 हटा दिया हमने, nothing else.
No, you were saying some point about it.
Hi, that is the, see, oh, I was saying that this pressure of H2O, pressure of H2 is only the vapor pressure, right? It is the vapor pressure because These are the gases, these are the vapors, they are applying pressure, that is the P of H2O. And that is also equal to the Kp. That means vapor pressure is the equilibrium constant. Vapor pressure is the equilibrium constant. Got it?
Yeah, yes, sir.
Okay. Please write this down. Raise your hand when you are done. माजिया नोट्स नहीं मिले होंगे ना आपको अभी तक? Yes, Mazia. I don't know why this is happening. सैयद मोहम्मद अभी ज्वाइन किया है, उन्होंने बताइए इतना नहीं। Waiting for Samson. Samson, how are you?
I'm fine, sir.
Okay. You have missed concentration terms, am I right?
Yes, sir.
So 4 p.m. KSA timing. You will have a backup class of concentration term on 4 p.m. KSA. Is that all right?
Yes, sir.
Okay. You'll also get a message regarding this. Okay, 4 p.m. KSA time, Friday. Friday. 4 p.m.
Sir, I can't be there on Fridays.
Why?
Because I have church, like the whole day I'm busy with church stuff.
Whole day?
Yeah, mostly like from 9 to 2 I have church, and after that till 7 I'm busy with other church activities.
And after 2 till 7?
Yeah, after 2 to 7 I'm busy with church activities.
Oh, okay. And I don't think then you will be having any other days also, right?
No, not any other days.
So Friday is a holiday in your school. That is why I chose Friday. And the other days you will be having school plus the coaching also, right?
Sir, Saturday no school.
Saturday there is no school. Saturday no school. You don't have school, but Saturday I have classes. Now Friday ko mera bhi off rehta, so I can take classes on Friday only. Saturday. Just see. So you can do one thing, Samson. Friday we'll be dealing with concentration terms. That will be recorded. Okay.
Okay.
And then you can watch the recording on Saturday.
Okay, sir.
Okay, watch on Saturday. Achha, while you are watching, if you have any doubt, okay. For example, let us say this is a 1.5 hour lecture on Friday. You watch it all. You have some doubts. Then what you are going to do? You are going to message Learnivio that I need a class with Salim sir. Okay.
Okay, sir.
And in that we can clear up your doubts.
Yes,
Okay?
sir. Yes, sir.
But do me a favor that you watch it. Can you watch it in the first half, like before lunch, so that I can take your class somewhere? If you have any doubt, then I can take it at 2 p.m. or something. So 2 बजे तक आप देख लीजिए. उसके बाद I can take the doubt class. ठीक है?
Okay, sir.
All good? चलो.
Okay.
So all of you have written this, right? Now, all of you have written this. Now let us say, what are the factors that affect the vapor pressure? Factors affecting vapor pressure of liquids. Okay, so see, the first one will be obviously the vapor pressure of water will be greater than the vapor pressure of what? Vapor pressure of Roux. Also, one more thing, if I have sanitizer here, okay, And if I have water here, so here we have sanitizer, and here I'm having water. So tell me which will be evaporating easily, sanitizer or water? Which will evaporate easily? Array?
Sanitizer.
All of you, right? Sanitizer. Correct? Yes or no?
Yes.
See, those who are having a bit of doubt, अभी एक बात बताइए. You take a few drops of water and you rub it on your palm. Then your hand is wet or are they dry? Tell me. Mazia, Matthew, Khalil, Ishma. If you take some water and you rub it over your palm is wet or is it dry?
Wet.
Wet. All of you, right? Yes or no? Minashi,
Yeah.
Mazia, Nawal.
Yes,
है ना?
sir.
Wet. But if you take a few drops of sanitizer and you rub it over your palm, your hand is dry or it is wet?
It gets
Dry.
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 It gets dry, right? So that means whose vapor pressure will be higher? Sanitizer. It is getting converted to vapors easily. If it is getting converted to vapor easily, that means it will be having more vapors. More vapors means more pressure. So vapor pressure of sanitizer will be higher than that of water. So the nature of liquid is the first thing. Nature of liquid. It means what liquid are we seeing or what liquid are we comparing here? So nature of liquid. Nature of liquid. Okay. And in nature of liquid, we can say that liquids with strong IMF. What is IMF? What is IMF? Tell me.
Intermolecular force.
Yes, correct. Let me write it here. Intermolecular forces. Okay. So liquids with strong intermolecular forces have. So if you are having strong intermolecular forces, the molecules will be sticking together. Yes or no? The molecule will be sticking together. Array, is yes or no? The molecules will be sticking together now.
Yes.
Okay. If they are sticking together, that means the vapor pressure will be high or low. Tell me, the vapor pressure will be high or low?
Low.
Low. The liquids with strong intermolecular forces have low vapor pressure. Is this understood? Yes or no? Everyone is with me? Liquid with
Yes,
strong? Okay. Second is temperature. Okay. So it only depends on two things. Nature of liquid, because it is a equilibrium constant, it will depend only on the nature of liquid and the temperature. Nature of liquid and the temperature. So now you all will tell me for temperature, what will happen if I increase the temperature? The vapor pressure will increase or decrease? Tell me. What will happen to the vapor pressure if I
Increase.
increase the temperature?
It will
Sorry?
increase, I think.
Increase, right? Yeah, it will increase. Think about water, na? So what will happen? If you heat it, more and more water will get converted into vapor. If more and more water is getting converted into vapor, those vapor will be applying pressure and that pressure will be more. So vapor pressure of a volatile substance. Volatile substance is anything that is going to give you vapors. Okay? Vapor pressure of a volatile substance increases with increase in temperature. Increases with increase in temperature. Is that clear? Yes or no? Please tell me. Next thing is that boiling point. Okay? Very important thing, boiling point. Who will define boiling point? Tell me. Boiling point कौन define करेगा? What do you understand by boiling point?
Temperature at which liquid changes to vapor.
So, like you have seen that water gets spilled, right, Zarsh? Yes, Zarsh, you have seen the water getting spilled on floor or something. Ah, yeah, na.
Yes, can
Yes.
you?
Ah, I can hear you. You have seen water getting spilled, right?
Yes.
So, what happens? Do you have to heat it? उसको boil करते हैं क्या? To
No.
make it vapor. So, what is the difference? There also it is getting converted into vapor, right?
Yes.
So,
That's
think now. हाँ बोलिए.
That's evaporation.
So how is it different? दोनों का तो definition same हो गया ना फिर आपके लिहाज से. Evaporation, in evaporation what happens? How will you define evaporation? Tell me. You'll say the same thing. Water getting converted into vapor. Anyone? What is boiling point?
The minimum temperature required to change liquid to gas.
Minimum temperature. So what is the boiling point of water? Ishma, what is the boiling point of water?
100 degrees Celsius.
यानी कि पानी 25 डिग्री सेल्सियस में हम ऐसे गिरा के रख दें तो वो कन्वर्ट ही नहीं होता है. Yes, Ishma, it gets converted, right? Salman, you are also saying the same thing. You are also saying the same thing. You're saying that the point of temperature in which water turns into gas. So water also turns into gas at 25 degrees Celsius na, through evaporation. All of us know this, that all water will get converted. If you spill a glass of water and just leave it there, then also it is going to convert into, going to convert into gas. Okay.
The temperature
Now,
at which water changes or a liquid changes its state from a liquid to a gas.
अरे सबको ही तो यही बोल रहे हैं, liquid to a gas. Just wait a second.
Okay.
All of you are saying the same thing only, na? फर्क कहाँ है? Hania, where did you come to know about this?
In school.
In school. Okay. Can you explain it how? Why? But like you have learned this in school, but they have just given you this definition, right? चलिए. So now you will understand this, ठीक है? हम लोग ऐसे नहीं पढ़ेंगे. Learning by
Defined as
inquisition.
when vapor pressure of the liquid is equal to the atmospheric pressure.
हाँ, सब बहुत बढ़िया है ना. सब ऐसे किताब मार मार के छान मार के आ जाओ. Why? How? Tell me. कहाँ vapor pressure कहाँ से आ गया? If I ask you, see, we have to get to one more level of why, na? What is boiling point? You have defined it correctly. Very good. Okay. So do you also want me to just define it and go ahead? नहीं ना? We have to understand this, right? How it is happening. चलिए. अब देखते हैं कि बिना स्कूल के आप लोग इस चीज को जान सकते थे कि नहीं जान सकते थे. ठीक है? Without school or without me also, ऐसा हो सकता था कि क्या आप मतलब you saw this process of boiling and you are like, oh, okay, so this is boiling point. ठीक है? So we will do a thought experiment. What is a thought experiment? Thought experiment in which you don't have to do anything. You are just sitting there and you're just thinking of something, and then in your thoughts you're doing some experiments. We have a container of water like this. We have covered this with a lid. Okay, we have covered this with a lid. ऐसे ये एयर टाइट नहीं है, ऐसे बस हमने ढक्कन रख दिया उसके ऊपर. Okay, and then we have gas stove, and from gas stove we are getting heat out. बोलिएगा आप, सर ब्लू फ्लेम निकलता है हमारे में से, तो लीजिए ब्लू फ्लेम. ओके, एंड देन यू आर सिटिंग हियर बिट अवे. ठीक है, यू आर सिटिंग अ बिट अवे. आराम से, यू आर लेइंग समवेयर. ओके, now you tell me, that if you are sitting here like this, will you be able to point out that okay fine, now the boiling has started? ऐसा कर सकते हैं आप लोग while sitting here? Tell me. Think what will happen when it boils, है ना? आप अपने आप को मत सोचिए. The point at which देख लो, I guess इतना लंबा डेफिनेशन लेके इतना ज्यादा कौन गेस करता है? नहीं, that is not right. इक्विलिब्रियम वाला तो वेपर प्रेशर इवेपोरेशन बोलते हैं उसको, सैयद मोहम्मद. ओके, all of you get to this scenario. All of you can imagine this scenario, yes or no? Samson, Hania, Ishma, Khalil, Khalid, Khalil, Matthew, Mazia, Minashi, Nawaz. So many students. Sayyid Muhammad, Zarsh. Huh? All of you
Yes,
can
sir.
imagine this? Right.
Yes.
Okay, so now you start thinking, what are the changes? What are the changes that you can see from away? Right? What will happen when this water will start to boil? So this is the only thing that is visible to you, ना? अब इसमें क्या changes आ रहे होंगे जब पानी boil करना चालू करेगा तो? You can't see it. No, you can only see it is, first of all, it is covered, right, Matthew? First of all, it is covered. Then how will you see the vapors? Yes, thank you, Khalil. I'm waiting for a few more answers like this. Tell me, think and tell me. बोलिए, कुछ भी बोलिए. How will you see a pressure? Salman, what will you see? I'm asking, na?
Oh, okay.
Sound. You're sitting a bit more far away. I would say that sound आप नहीं सुन पाइएगा. Yes, Matthew. See. Okay. Yes, Salman, correct. No. Okay, fine. I'm looking for a few more answers. ठीक है. So this is what science is, na? Like all of you are giving same answers, na? Matthew, Salman, Khalil, all of you are giving me one answer, and if I say that answer, everyone, all of you will agree. Or it is that आपके दिमाग में strike भी किया होगा, लेकिन आपको लगा ये तो ना पूछ रहे होंगे सर. So the lid will start shaking. Is that right? Yes or no? Hania, Hishma,
Yes, sir.
Samaira, right? So this striked your brain. I hope so. When I was asking what are the changes you will see. Yes or no, Zarsh, Samaira, Nawal?
Yes.
Right? Okay. So see, I am looking for these type of answers only. अगर आपके दिमाग में कुछ भी आया ना जो हो सकता है exactly, उसको बोल दिया कीजिए. Now, why was the lid not shaking previously? Why was the lid not shaking previously? Because it was under the influence of a pressure, and that pressure was equal to how much? 1 atm. The atmospheric pressure. Correct hai? Yes or no? Is that right?
Yes.
है ना? Now it is stable. But what will happen slowly? Slowly the water will become vapor. They will evaporate. है ना? And slowly, so much water vapor will be here. So much water vapor will be here that they will be applying a pressure that is equal to 1 atm again. So this is also applying a pressure of 1 atm. Okay, so as soon as the vapor pressure of liquid, and that means inside the container, it becomes equal to the atmospheric pressure. It becomes equal to the atmospheric pressure. What happens? Boiling starts. Okay, so that is the time boiling will start. That is the time you will see the lid shaking a bit, lid losing its balance. Okay, so 1 atm here, and from 1 atm, that is also from the vapor pressure. Is that clear? Yes or no? All of you tell me.
Yes, sir.
Okay. So always remember this scenario whenever you are talking about boiling point. Okay. So this is what boiling point is. Now you can explain this to anyone, right? The temperature at which the temperature at which vapor pressure of a liquid is equal to the atmospheric pressure or the external pressure. Or the external pressure. So if there is a liquid which is volatile, that means whose vapor pressure is already too high, for example, sanitizer and all, so those will be getting boiled more easily. They will be getting boiled more easily. That means at a lower temperature. So you can write liquids with high vapor pressure have wait a second, sorry, have low boiling point. और स्क्रॉल करना है क्या खाली?
Yes, sir.
कहाँ तक बताइए?
Yes, sir.
ठीक है यहाँ तक? फैक्टर्स अफेक्टिंग वेपर प्रेशर ऑफ लिक्विड.
Yes, sir. Done, sir.
Done. Okay. Boiling point लिखिए आप लोग. All of you write about boiling point. The temperature at which vapor pressure of a liquid is equal to the atmospheric pressure. And also the liquids with high vapor pressure will have low boiling point. With high pressure will have low boiling point. So you can also write a proportionality sign here. That boiling point is inversely proportional to vapor pressure. So Darsh, you were born in like you said, have you spent any time in Ranchi in childhood or something?
Yes, sir.
Like
Till,
till what standard?
till second standard, I was in India.
अच्छा till second standard only. तब तो बहुत छोटे होंगे आप.
जी.
Like since I'm from village, but I have done my at class 9, a small age of class 9, I left my home and I went to Jamia Millia Islamia, Delhi at 9th standard. But I used to take trains from Ranchi only. So do you know Farayalal in Ranchi?
Yes, sir.
उसके नीचे आइसक्रीम मिलता है, right?
हाँ, वो मॉल है ना.
हाँ, yeah. Farayalal, I don't think it is a mall, but it only sells like ethnic clothes, I think. सिर्फ कपड़े की दुकान है ना?
हाँ, वहाँ पे कश्मीर वस्त्रालय भी है.
हाँ, yeah, that is Kashmir Masala and all. So I used to have like whenever we used to go to Ranchi and Farayalal, we used to have ice cream there. Those who are not from Jharkhand, they don't have the idea like it can be beautiful. But not telling this to people from Kerala, because I know Kerala is way more beautiful. But that the beauty is like similar of Kerala and Jharkhand also. The only difference is that I see in Kerala you have beautiful homes also. Even the village people, the homes in Kerala also, they look like they are made by nature itself. They are so close to nature. The ones that I have seen, they are very nicely made and all. But in Jharkhand, I don't know why, because I think it is due to the influence of industry that we have in Bokaro and Jamshedpur. The buildings are not that, what I will say, they don't have any cultural importance. The buildings that are made by here by people only. So they are just like houses where humans live. But Kerala is very beautiful.
Yes, sir, because Kerala is very stuck to their cultural roots. They
It's
value
it's
that
very
more than urbanization.
Hmm. Yeah, and that should be preserved, I would say. At the end, that is only going to save you. Urbanization, it can feed you well. It can feed you well, but after a point, you don't. I mean, your stomach is full, you know, your plate is full. So after that, you need your values and culture only.
Yeah, there's this whole like uh, train issue in India because the government's trying to install like a big like hyperloop train in Kerala, and because of
Okay.
that, many people's homes are going. So there's a whole protest against it, and that like shows how
Acha, so,
culturally important it is.
oh, so acha, they are making hyperloop there also. I think it was happening in some Bangalore type of places. I did not know about Kerala. I also have like a kind of soft heart for Kerala and people from Kerala because my schooling was done till 8th standard here in my village only. There is a school that is all run by the whole management is from Kerala, and it is also run by some Kerala Welfare and Education Society. So all my teachers, like from 4th standard, I think, yeah, from 4th standard to 8th standard, they were all from Kerala only. And also always had good friends from Kerala. Like even when I was in Jamia, then I was in my masters, I did not have any classmates from Kerala, but two of my seniors, they were from two of my seniors, yeah, two of my seniors, they were from Kerala. One was from Chennai also. Khair, done with boiling point, yes or no?
Yes, sir.
Yes, sir.
Okay, fine. Chaliye. Ab, now it is the point of importance. Raoult's law. Okay. But again, before moving to Raoult's law and writing everything about Raoult's law, let us now understand how Raoult would have come to this, how they would have derived this law. So it is about the vapor pressure of two liquids. When you mix two liquids, now then what is the vapor pressure of the two liquids is going to be. So science is like there is always a debate between the not scientists, but the scientists who are more into philosophy, the people who are into the philosophy of science. What is science? So science can be two things. It can be either explanation, okay, what is the thing that is happening, and how it is happening, those things. But there is a few, not few, I would say, there is another school of thought that says that science is about prediction, but generally it is a loop kind of thing. You explain something and then you make a law for that, and then you predict something. Then again, with prediction you can get a few more type of explanation. Just for example, Newton first law of motion, right? So it is giving you a law also, and it is also explaining a few things. So similarly here also, Raoult's law, I will explain things, then we will also derive the equation. Acha, one more thing about science. There are a few things which are known as law hote hain, then you have rules, okay, then what else do you have? Then you have theories, okay. So see, law is anything that is mathematical in nature. Iske equation mil jayenge aapko, okay. Rule is something that you saw some pattern, and a pattern you saw and then you generalized it. Now theories, it is also theory. May please don't think that theory hai to sirf uska, like it is just theory, it is not backed with any factual, or it is not backed with any evidence. Ye sirf khayalat hai. Don't think about theories like that. Theories are also laws, but not mathematical. Okay, these are not mathematical, but these also have the same level as that of law, and like there cannot be anything above theory. For example, you don't need maths for each and everything, right? In order to explain, or in order to give some kind of explanation, you don't need maths each and every time. So those parts, these are taken care by theories. Now in chemistry you will be hearing that exception hota hai, that is only in rules, है ना? Only in rules you will be finding exceptions. For example, boiling point, for example, the ionization enthalpy में ये rule है ना, that this is the pattern that you are seeing. If I go down the group, then the ionization enthalpy, it will decrease because the ionic radius is increasing. So that is a pattern generalization. Then you are ought to be having some kind of, there will be some kind of exception. but laws they don't have any exception. For example, Henry's law का कोई exception नहीं है, right? Raoult's law will not have exceptions. Similarly, your van der Waal gas law, it does not have any exception because these are laws and these are mathematically proven. Okay. Okay. Now, what is Raoult's law? Let us understand by taking two liquids. Oh, wait a second. What is the time? Actually, there are time. You have half an hour or something? Half an hour. Don't write this, है ना? Don't write this. Yeah, we are A liquid and liquid that is B, है ना? Sometimes I may also write this. ध्यान नहीं रहता तो 1 और 2 भी इसको ले लेते हैं, ठीक है? A, B, 1 or 2. You can call it anything. Now, individually, if I see the vapor pressure, then I will say that the vapor pressure of A is how much? I will say it is equal to P naught A. Okay, when you have just A, the vapor pressure of B is P naught B. So the naught here, it is representing pure and A means A. So vapor pressure of pure A is P naught A. Vapor pressure of pure B is P naught B. यहाँ तक clear है सबको about the terminology? Yes or no? Please tell me.
Yes, sir.
Everything is clear, right? Everything is clear. Now, when we have mixed something, so we have mixed. Let us take that we have taken the solvent as A, and we have added some B also here. Okay, we have added some B also here. Okay. Now these things are not pure, right? It is not pure. So we can say that the water, it will have that means the PA. Due to PA, we will have PA pressure, and not P naught A. Why? Because it is not pure. We cannot have P naught A pressure due to the A liquid because it is not pure. Similarly, this red liquid will have some pressure, and that will be PB. Correct? Yes or no? You understand these 2 points? The red one will be giving out some liquid, and some liquid from some liquid from A will be escaping out. It will be converting into vapors, and it will be applying the pressure PA. From the B liquid, some of it will be escaping out. It will be converting into vapor, and it will be applying a pressure of PB. Is that clear? Yes or no? Please tell me. यहाँ तक clear है सबको?
Sir, can you please explain again?
Explain again. Okay, fine. So can I say that some of the liquid A, it will be escaping out, है ना, due to evaporation, and it will be applying a pressure of PA. Correct? Yes or no? ये समझ में आ रहा है तो बताइए.
Yes, sir.
And it will not apply the pressure P naught A because it is not pure. Correct? Yes or no?
Yes.
है ना? Right now it will not apply. Similarly, you will have some red particles which will be escaping out of the system because it is also liquid, right? It is also liquid, and some of it will be also escaping out of the system, and the pressure that will be applied, it will be PB. Is that correct? Yes or no? Tell me, Anya.
Yes.
Okay. Okay. So now the total pressure will be equal to the total pressure that you will be experiencing due to A and B. It will be equal to the partial pressure that is applied by A and the partial pressure that is applied by B. Correct? All of you tell me yes or no. PA plus PB, and PA plus PB. Now, let us see what PA will be equal to and what PB will be equal to. What PA will be equal to and what PB will be equal to. So, I can say PA, it will be equal to, जब ये pure था, if you just have, please listen, if you just have A, that means in this case, it will be equal to 1 into P naught A. Correct? Yes or no? Please tell me.
Yes.
If you just have pure A, सिर्फ pure A है तो it will be that much. Now, as soon as I have the mixture, then can I say some fraction of P naught A is here, right? There is whole total pressure, there is whole total, and from total we have some amount of PA. Correct? Yes or no? Some amount of A is present out of total, and it is like mole fraction, right? It is like mole fraction only. You have P naught A divided by total, and that is why the PA in the mixture will be equal to the fraction of A present there multiplied by the original pressure, that is the pure pressure, that is by A. The second point, is that understood? Yes or no? Please tell me. Can you make this up? Chi A into P naught A. Let me also say here, this first equation can also be proved. When you just have A here, pure A, if you have pure A, then the mole fraction of A will be equal to the number of moles of A divided by the total moles. The total mole is also what? Number of moles of A only. This will be equal to 1. Can you see that? Yes or no? Please tell me.
Yes.
Hana?
Yes, sir.
So, okay. So in the mixture, what will be the pressure in the mixture? PA will be equal to the mole fraction of PA multiplied by the pure vapor pressure of A multiplied by the P naught A. Is that clear? Yes or no? Similarly, we will have PB, which will be chi B into the pure pressure of B. Is that clear? Sabko, please tell me yes or no?
Yes.
Okay. Then you have, I can say the total pressure. Total pressure. This will be equal to P naught A chi A. And here PA plus P naught B chi B. So this is the Raoult's law. Now what we'll do? We have explained it. Now we will write it. Okay. We'll write what is Raoult's law. You don't have to write anything here. वो सारी चीजें हम लोग अब लिख देंगे. So write the heading Raoult's law. I think RAOU है. Raoult's law. Now, what is Raoult's law? Please write. For a solution of volatile liquids, the partial vapor pressure of the partial vapor pressure of each component, partial vapor pressure of each component is directly proportional to its mole fraction. Okay, directly proportional to its mole fraction. Now see, now from Raoult's law you can also explain the previous point, that if I have PA, partial pressure of A, it is directly proportional to chi A. It is directly proportional to chi A. Now please listen very carefully. We can write here PA, it is equal to some constant into chi A. Correct? Yes or no? Please tell me. Yes or no? Some constant है ना? देखिए अब ये हम लोगों को देखना है कि what is this constant here? What is this constant here? Now, in order to get the constant, what we can do? We can take the chi A. Constant will be the same, na? If the chi A is equal to 1, 2, 3, 4, 5, कुछ भी हो. Sorry, not 1, 2, 3, 4, 5. If it is 0.1, 0.2, 0.3, 0.3, 4, 5, 6, anything, the chi A can be of any value, but the constant will be constant. So what we are going to take? We are going to take this chi A as unity. That means 1. So now, please listen very carefully, when chi A is equal to 1, then the P naught A, the PA, it is equal to K, and this will be equal to what? P naught A. Because why? Because we just have, when chi A is equal to 1, PA will be equal to P naught A. Is that right? because of pure A. जब chi A 1 हो गया, when the mole fraction is 1, that means you only have A in the solution. There is no other solute. There is no other liquid that is in the solution. And if there is no other liquid in the solution, then the pressure that is applied by that liquid will be equal to the pure vapor pressure. है ना? Vapor pressure due to pure A. And that is why K is equal to what? The K is equal to P naught A. And hence you can write PA is equal to P naught A chi A. So this is the result of Raoult's law. PA is equal to P naught A chi A. For a solution of volatile liquids, the partial vapor pressure of each component is directly proportional to mole fraction, and from directly proportional to mole fraction, we come to this equation that partial pressure is equal to the vapor pressure, the pure vapor pressure into the mole fraction. Can I move on? Yes or no? Please tell me.
Sir, can you
लिखा है, लिखे लिखे लिखे.
Yes, sir.
ये लाइन सबको समझ में आई ना? प्लीज टेल मी. Zarsh, Hania, Mazia, Minashi, Matthew.
Yes, sir.
All of you understood this, no? Okay. Is there anyone who is still writing? No one is writing? Okay.
No, sir.
Now, please write me for a solution with liquid A and liquid B. With liquid A and liquid B, P total, that means total vapor pressure, will be equal to the pressure applied by A plus the pressure applied by B. And I hope you remember this is through Dalton's law of partial pressure, right? Total pressure of a solution. Total pressure of a solution is equal to what? It is equal to the sum of partial pressure. Right? Total pressure, like it here, total pressure is sum of partial pressure of each component. Okay, now P total will be equal to P naught A chi A plus P naught B chi B. So P naught A, this is coming from here and this is coming from here, and all of these two equations is from Raoult's law. जो अभी हम लोगों ने लिखा है यहाँ पे ऊपर. PA is equal to P naught A chi A. P naught A chi A. Okay, so this is the definition of Raoult's law. इसको आप याद रखिएगा. And there is also one more way in which we can write this law. There's one more way in which we can write this law, and that way is what? Since, okay, so all of us know what? All of us know that chi A plus chi B is equal to 1. Chi A plus chi B, it is equal to 1. So what we can write? We can write chi A is equal to 1 minus chi B, and P total will be equal to P naught A. For chi A, we will write 1 minus chi B plus P naught B chi B. अब इसी को expand जब हम कर देंगे, this will be equal to P naught A minus this will be equal to what? P naught A chi B plus P naught B chi B, है ना? P naught B chi B. अच्छा, अब from here what we can see, here also we have chi B, here also we have chi B, so that can be taken common, so we will have P naught A. Now P naught A, please listen यहाँ पे carefully, plus कर दिया हमने, and what I can say, PB minus PA, है ना? P naught B minus P naught A. All of you understood this? मैथ से बस थोड़ा ध्यान दे दीजिएगा तो आ जाएगा आपको. Let me know if you have any difficulty from this step to this step. ठीक है? चलिए, write this down. Then we will look at the plot of Raoult's law. Okay. Or Hania, you want me to scroll a bit more up?
Okay. No, sir, thank you.
चलो. Done all of you? Yes or no? Please tell me. Not done?
Done.
Samson, tell me. Done? Okay. Is there anyone who's still writing? Should I move on? No one is writing. Okay. Right. Graph for Raoult's law. Okay, graph for Raoult's law. Now, please listen यहाँ पे, ठीक है? Please listen. Don't write anything. Okay, don't write. Please don't even make the plot. ठीक है? बस ये topic heading डाल लीजिए, graph for Raoult's law. उसके बाद let us start like this. Let us start like this. Let us say that at this point, the mole fraction that is chi b, it is equal to 0. है ना? हमने कुछ नहीं start किया, ये तो 0 point है. Chi b equal to 0. Yes or no? Please tell me. Chi b will be equal to 0. हाँ या ना? अरे, I have not added any solute. This point will be chi b is equal to 0, and I will be in this range. I will be starting to plot with for chi b. Is that correct?
Yes, sir.
Yes.
ठीक है. Now अब देखिए. If chi b is equal to 0, chi a will be equal to how much?
1.
Very good. If chi a is equal to 1, That
1
means if I'm
minus
plot,
chi b.
हाँ तो 1
Okay,
ही हो
then.
जाएगा ना.
Yeah.
हाँ ठीक है. All of you understand ना? Chi will be equal to 1. है कि नहीं?
Yes,
बताइए.
sir. Yes, sir.
Right? Okay, fine. So and in this way, here we are plotting for pressure. Here we are plotting for pressure. Now, if chi is equal to 1, then we have pure A. If we have pure A, that means the pressure will be equal to what? At this point, I can say that the pressure is equal to, let us say, कहाँ पे रखें ये pressure, यहाँ पे हमने रख दिया, दिखने नहीं बन रहा है अब. यहाँ पर. So this will be equal to P naught A. Is that clear? Yes or no? Is that clear? Yes or no? Please tell me.
Yes.
Okay. Similarly, यहाँ पे देखिए. So chi b क्या होगा? Chi b will start to increase, and it will become chi b is equal to 1. उसके आगे तो जा नहीं सकता है ना? And since it cannot go further, we can also draw something like this, and that is why it is having a bit of complicated graph. And let us say that this is the point, and at this point you will just have what? Pure b, है ना? And chi a will be equal to 0 here. Chi a will be equal to 0 here, and let us say that chi b is more volatile, or it has more vapor pressure. So this will be P naught of b, and you just join these 2 points, and you will be getting the plot for Raoult's law. Okay, plot for Raoult's law. But if I look at these two individually, now when we are talking about this point here, at this point I can say that PA, the partial pressure due to A will be यहाँ पे P naught A, and the partial pressure due to B, it will be lower. If I plot this graph like this, इस plot को देखिएगा, है ना? So what is this plot telling me? This plot is telling me that this line is for PB. Partial pressure due to B. It will be 0 here because we don't have any. It will be 0 here because we don't have any molecules of B. It will be 0, and slowly it will increase because we are increasing the mole fraction of B, and the opposite will be true if I draw for PA. So PA के लिए क्या होगा? PA के लिए यहाँ से start करेंगे, and we will be ending up here. Okay. Generally, these plots are shown by dotted lines. So keeping that convention. Okay. So this plot here, it is giving me about PA. Okay, this is about PA. Please draw this plot, and this plot here, that is with complete state plot. This is telling me about the no, so P total will be equal to PA plus P. Okay, this will be equal to PA plus P. यहाँ पे भी pressure है. Here also you are having the pressure on both the axes. चलिए, please write this down. Let me know when you're done. Please let me know if you don't understand any of the plots. If you understand the people, then also you can tell me. If you don't understand why is that line PA or why is that line PB, then also tell me. We will talk and we will understand it. Fazia is done. Okay. Okay. All of you are done? Yes or no? Is there anyone who's still writing?
Done, sir.
Done? Okay, fine. चलिए एक सवाल लिख लेते हैं and then we'll be done with the Raoult's law. Please write this question. An aqueous solution of glucose is made by dissolving 10 gram of glucose in 90 gram of water at 303 Kelvin. If vapor pressure of pure water at 303 Kelvin is 32.8 mm of Hg, what will be the vapor pressure of the solution? C6H12O6 mixed with 90 gram of H2O. Okay. So this is what? This is my chi B, right? This is my chi B. That is the solute here. This is the solvent here. Please write this down. 10 gram of glucose mixed with 90 gram of water. 10 gram of glucose mixed with 90 gram of water. 10 gram of glucose mixed with 90 gram of water. So I can see that we will have water. And they are asking what will be the vapor pressure of the solution. So vapor pressure is equal to what? P total is equal to PA plus PB. PA plus PB. Now 90 gram of water. This is what PA. And it will be equal to P naught A chi A. Okay. Similarly, 10 gram of water से हम लोग क्या निकाल सकते हैं? We can say that this is PB solute and this will be equal to P naught B chi B. Is that clear? All of you tell me. Till here is this clear? Yes or no?
Yes.
है ना? अब यहाँ पे देखिए. What is PB? That is the vapor pressure of pure glucose. Is that right? Yes or no? Please tell me. Vapor pressure of pure glucose ना P naught B. हाँ या ना बोलिए. हानिया, हिश्मा, खालिद, खलील. Right? ये कितना हो जाएगा बताइए. What is the vapor pressure of pure glucose? What will be the vapor pressure of pure glucose? All of you have seen glucose, yes or no?
Yes, sir.
Yeah.
Yes. So उससे vapors निकलते हैं क्या? Glucose से? Does it evaporate?
No.
No, right? It is a solid. So vapor pressure of pure glucose is equal to 0, and hence this PB will also be equal to 0. And the only in the total pressure, the only component that will be there will be due to the water. You will be having pressure that the vapor pressure of solution will only be due to water, not because of glucose, because P naught B, that is the vapor pressure of pure glucose, it is equal to 0 as it is non-volatile solid. It is non-volatile and it is a solid. Is that clear? Yes or no? Please tell me.
Yeah, sir.
Yes, sir.
है ना? Okay. So we need to calculate the number of moles of both the things, glucose and water, in order to calculate the A. है ना? So number of moles of A, it will be equal to 90 gram divided by 80 grams per mole. Okay. So cancel this, cancel this. So this will be equal to how much? Tell me. How many moles? 90 upon 18. जल्दी बताइए. 90 upon 18.
5.
Yes, correct. 5.
5.
5 mole. है ना? Then NB. This will be equal to. Does anyone remember what is the molar mass for glucose? किया है हमने क्लास में. ये भी कहा था हमने कि याद करके रखिएगा. Okay, somebody remembers. Yes, Syed Mohammed, thank you very much. 180 grams per mole. If you calculate this now, then this will be equal to, I think, 100 होने से कितना होता था? 5.0 point something ना 0.555 ठीक है हाँ 0.056 कर लेते हैं because it will be 5555 0.056 moles. Okay, now from here what you can do, from here you can calculate the chi mole fraction of A. It will be equal to number of moles of A divided by number of moles of A plus number of moles of B. It will be equal to 5 upon 5 plus 0.056, which will be equal to 5 upon 5.056. Tell me approximately what will be this value. .99 लिख लिया हम.
Around 0.98.
98. I think it will be like 0.99, near to
Yeah.
0.99. है ना?
Yeah, it's near to 99. Yeah.
0.99 के करीब होगा ये. नहीं सलमान, it will be not 0.899. 0.8 तो होगा ही नहीं for sure. It will be 0.9 something.
Yes, I by mistake typed that 0.98 something.
अच्छा ठीक है. I think it will be 0.989 आ रहा होगा जहाँ तक मुझे याद आ रहा है. So you can write that 0.99. ठीक है. Now you can write the P total. So P total is equal to P naught A chi A plus P naught B chi B, है ना? And what is P naught A that they have given? P naught A कितना दिया इन्होंने? 32.8. So 32.8 mm of Hg multiplied by 0.99 plus 0 into chi B, है ना? So this will be equal to 32.8 into 0.99. Solve this and tell me. Simplify this, calculate this and tell me what is the answer. So this will be equal to 32.47 mm of Hg. This will be the total pressure. Okay. Write this down. All of you understood this question? Yes or no? Please tell me. Zarsh, Matthew,
Yes.
Samson. Yes. Okay.
Understood.
What about you, Samaira, Nawal, Minashi,
Yes,
Mazia?
Yes, sir.
Okay, fine. So understood the concept of vapor pressure and Raoult's law today, है ना? You understood the concept of vapor pressure, Raoult's law, and also most importantly boiling point. Most importantly boiling point. Okay. So can I stop sharing the screen?
Sure,
Should
sir.
I stop? Okay.
You show
Fine.
the
All of you have written.
question.
हाँ बताए. Question again. लीजिए. Here are question. So in the next lecture we will be doing a few more questions, few more numericals. Some of the numericals will also be there in your assignment, and then we will understand. And you must also see that it is kind of Henry's law only, because in Henry's law क्या था? If you remember the Henry's law, it was the pressure was equal to, right? So K is what? Here the pressure is equal to P naught A. If I take for the If I take the PB, then it will be P naught B into chi B, right? So KH and P naught B, these are kind of same. So Raoult's law is also known as a special case for Henry's law. You'll understand that point also.